fraction is a part of a whole. So let's say you have one whole pizza and you slice it 12 times. So if you get 3 slices on it, those 3 triangles is a fraction of 12. So that's 3 over 12. And before, we learned that to add fractions, in order to combine them, we need to have the same denominators. So if we have 1/4 plus 1/4, since 4 and 4, these two fractions got the same denominators, it's easy to add. We can get 2 over 4 or 1/2. That's how fraction works. Or if it has not the same denominators or different denominators, like 1/2 and 1/3, our goal is to find this common denominator. So 6 divided by 2 is 3 times 1 is 3. And 6 divided by 3 is 2 times 1 is 2. So that's 5 over 6. Similarly, if we have a rational fraction or a fraction that is in terms of algebraic terms, or let's say polynomials, 1 over 5x plus 1 over 2x, we need also to find the common denominator before adding them, since 5x and 2x are not the same terms. Alright? And so with that, all we need to do is make them the same. So for 5x, we'll just have to multiply it by 2x. 2x over 2x. So nothing's changed here because 2x over 2x is still 1. So the equation is still balanced. But we managed to make denominators the same. So for 2x, we're gonna multiply it by 5x over 5x. So with that, notice that the denominators are now the same. And so we can now add them together. Next. So the reason why I am introducing this to you, the reason is, in partial fractions, we're doing the reverse. So instead of these terms adding together to make this a whole fraction, our goal is to make a whole fraction becomes its partial form. Alright? And this, ladies and gentlemen, my friends, is just the idea of partial fraction. This is the main idea of partial fraction. And so to understand the process, let's try some examples. So let's have 29 minus 3x all over x squared minus x minus 6. So how are we going to decompose it? How are we going to decompose this to its partial form? So the first step is to check whether the numerator is 1 degree less compared to denominator. Or in other words, if the denominator is x squared, then the numerator should be x to the first power or a constant. So the denominator here, as you can see, is just x squared and the numerator is of linear degree. So quadratic or linear over quadratic, so we're good to go. And then the next step is to factor the denominator. So get the factors. So if you're not good at factoring yet, I suggest to watch the video. The video is on the I button above. Just watch. I'll explain all the possible cases on factoring. It includes this type. So to factor this out, we need to to get the factors, we need to find two numbers that when multiplied together will give us -6, and if we add will give us -1. So it turns out that those numbers are -3 and +2. So the factors then will get x minus 3 and x plus 2. -3 times 2 is 6 and -3 plus 2 is -1. Alright? And then we just copy the denominator. After this, what we need to do is to have some random constant like a or b or any constant you want, any alphabet, a over the first factor. So the first factor is x minus 3. Or if you interchange this as x plus 2 times x minus 3, still you can put x plus 2 here. doesn't matter. So x minus 3, and then plus another constant b over x plus 2. So notice that this term here still follows the lesser degree over higher degree condition. So here x minus 3 is linear and a is a constant. X plus 2 is linear and b is a constant. So we're okay with that. Next step, multiply the whole equation with the denominator or the factors we have here. Multiply it all by this term or by that denominator. So x minus 3 times x plus 2. So with that, if we multiply it to the first term to the left, or this 29 minus 3x over x minus 3 over x plus 2 here, x minus 3 and x plus 2 will get cancelled out, and we're gonna left with only 29 minus 3x. And that's equal to, again, multiply this all in here so that it will become, this term will get cancelled out. So that's x plus 2 times a. So a times x plus 2. And then plus b times, this term will get cancelled out, times x minus 3. So now we've just set up an equation. This equation. And again, all we did is factor this x squared minus x minus 6, the denominator. And that's after checking if the conditions are met. So linear over quadratic. So it's good. And then if it's good, factor x squared minus x minus 6, or the denominator. So then we got x minus 3 and x plus 2. And then set up the constants. Random constant over the first factor plus random constant over the second factor. And then multiply all, or the both sides, by the factors. And now we got this. So all we need is to solve for a and b. So to do that, either we set up an equations, or we just plug in a value for x so that the terms a or b will cancel out simultaneously. So with that, let's assume x, or let's equate x, or let x be negative 2. So with that, if we plug in x to all, 29 minus 3 times negative 2, we've got a times negative 2 plus 2 cancelled out, because negative 2 plus 2 is 0, and 0 times a is 0. So plus b times negative 2 minus 3. So now what? We've only got this b as a known. So we can now solve for b. So 29 minus 6, or positive 6, is 25. And that's equal to negative 2 minus 3 is negative 5. And so b is equal to 25 divided by negative 5 is positive 5. Alright, because 5 times negative 5, negative 5, because negative 5 times negative 5 is 25. So now we've got our b. Next is to solve for the value of a. So again, let x, put some value for x, let x be what? Positive 3. So that we can cancel this b out. So with that, 29 minus 3 times 3, that's our x, is equal to a times x plus 2, or 3 plus 2. And then we got 29 minus 9 is 20. That's equal to a times 5. And so a is equal to 4. So we've got the value of a and b. And now that we have a and b, what are we going to do with that? Well, you will substitute that a and b to this random constant you've assumed a while ago, and then you've got the answer. So 29 minus 3x over x squared minus x minus 6, its partial fraction di should be 4 over x minus 3 plus negative 5 over x plus 2. So that's it, my friend. We've got this x, this term here, broken down or decomposed to its partial fractions, these two terms. Alright, that's for example number 1. Next we have, so now we have this example. So go ahead, try it yourself if you can do this and get its partial fraction. Are you done? So here's how to solve this. First things first, check if the degree of the denominator is bigger than the numerator. So here, the numerator is x squared and denominator is x cubed. So we can proceed. And then again, factor completely the denominator. So again, I am encouraging you to watch the video of mine about the video on this channel about factoring. It covers this type of factoring cubic polynomial as well. Anyways, 2x cubed minus 3x squared minus 2x, as you can see, have common. So that's x. So we can factor x out and we're gonna left with 2x squared minus 3x minus 2. And then by the use of AC method, this and then this, let's find two numbers that if we multiply together, we'll get negative 4, and if we add, we'll get negative 3. So those numbers are negative 4, 1, and positive 1. So we can break this down as 2x squared minus 4x plus 1 is equal to, minus 2. And then, this is 1x, or just x minus 2. Because negative 4x plus 1 is negative 3, and negative 4x times 1 is negative 2, or negative 4. And then factor out common. So this is how you get the factors of this denominator here. So here, we can group these terms and get their common. So in this group, the common term is 2x. And so if we factor out 2x, we're gonna left with x here, because 2x times x is 2x squared. Then minus 4x divided by 2x is what? It's just 2, right? 2x minus times negative 2 is negative 4x. And then plus this group. So this group has no common, so just write it down as x minus 2. And then if we pull out x minus 2, we'll get x minus 2 times 2x plus 1. So this is the factors of the above denominator. So it's just x minus 2, and 2x plus 1. So we're on the second step. Not the second step. So just copy denominator, 9x squared minus 15x minus 6. And then equate it to some random constant. So our first factor is x, so it's a over x plus b over x minus 2, and then plus 2x plus 1, so c over 2x plus 1. Then our goal here is to find two numbers. Notice that this still satisfies the condition because above is constant and below is a linear term. So again, let's make it a little bit smaller. Again, we're gonna multiply this by the factors and generate an equation, then solve for a, b, and c. So that's the whole process. So this would be x times x minus 2 times 2x plus 1. And so this term here, we're gonna left with 19x squared minus 15x minus 6. That would be equal to, here only x will get cancelled out, so a times x minus 2 times 2x plus 1. So let's make it smaller so we can have more space. Smaller. And then plus, for b, only x minus 2 will get cancelled out. So we're gonna left with b times x times 2x plus 1. For those of you that didn't see that, if we multiply b over x minus 2 by these terms, x times x minus 2, 2x plus 1, notice that this term will get cancelled out. So we're gonna multiply these three, bx and 2x plus 1. So that's what we're doing there. And then lastly, for c, it's just cx times x minus 2. So we've just generated an equation which has this a, b, and c here. Again, plug any values for x, so one or more terms will get cancelled out. So notice that if I put 0 here, x will get cancelled, b and c will get cancelled out. So let's do that real quick. At x equals 0, so b and c terms, these terms, will no longer exist. So a times 0 minus 2, 2 times 0 plus 1. And for the other side, 19, 0 squared minus 15 times 0 minus 6. So this will cancel out because that's all 0. Then negative 2 here, and then here it's just 1 equal to negative 6. So a is 3 because negative 6 divided by negative 2 is 3. So we've got the value of a. And then what? What's next? Are there any values that can cancel out if we plug in another number? I think there is. Because guess what? If I put 2 here, the a terms will cancel out. And if I put 2 here, these terms will get cancelled. So we can solve for b. So we're gonna put b. So 19 times 2 squared minus 15 times 2 minus 6 is equal to this b. b times 2 times 2 times 2 plus 1 closing quantity. So here 19 times 4 is what? It's 36, carry 3, that's 126. Am I right? Or not? 19 times 4, oh my god. 76, not 126. No brain. It's 76 minus 30 minus 6 is like minus 36. So 76 minus 36 is just 40. That's equal to b times 4 plus 1 is 5 times 2. b times 2 times 5. That's b times 10. And so b is equal to 40 divided by 10 is 4. So now we've got b. And now for c, are there any other values that if we put here, b will get cancelled? I guess it is negative 1/2. What you think? Because 2 times negative 1/2, the 2's will cancel, so it will become negative 1. And so negative 1 plus 1 is 0. Alright? So let's put negative 1/2 to all. So this will become 19 times negative 1/2 squared minus 15 times negative 1/2 minus 6. And that would be equal to, this term will get cancelled. This term will get cancelled. And so now we can solve for c, which is just negative 1/2 times negative 1/2 minus 2. So what's that? Negative 1/2 squared is 1/4. So 1/4, 19 over 4. Wait, let me write it as 19 over 4 minus, plus 15 over 2 minus 6 all over, equal to C times this one, negative 1 half minus 2 is the same as multiplying it by 2. So this will give us negative 1 half. So negative 1 minus 4. So negative 5 halves. So negative 1 half times negative 5 halves will give us 5 over 4. 5 over 4C. Now how about on this side? So it's just 25 over 4 over 4 equal to 5 over 4C. And so now C is equal to 25 divided by 5, which is 5. And so now, from the original expression, 9x squared over its partial fraction now is 3 over x plus 4 over x minus 2 and 5 over 2x plus 1. So that's it. The partial fraction of this in the left are this. So this next example here is a little bit different because its denominator is a repeated factor. So whenever you have this format, all you have to do is, of course, the first factor plus this second, but not this, but just what's inside. So x minus 3 and then plus another constant. And also, if you have this as 4, you have you need to have another constant, so it will become x minus 3 cube here, then plus x minus 3 to the fourth until you reach to the exponent, just like here. Alright, and solve for a, b, c, d, and e the way we solved it a while ago. So that's it. I will leave this example to you and try and solve this. And I hope you learn something from this video. Other cases is when we have a denominator or factors that are irreducible, just like this one, x squared plus 1. And if we have that, we just have to equate that to a constant. But notice, this is x squared plus 1. So, it's above numerator should be linear. So, we could write this as x squared plus 1. And then above as ax plus b. So, this is just the one that varies, or that's only different. But still, the process of solving for a and b is just the same. So, that's it. So that's it for this video, guys. I hope you learned something about partial fractions. It's just a matter of reverse process wherein from a whole fraction, you break it down to its partial form. Thanks for watching. Peace out.